first ever occasional lecture series in library technology here at the University of Alabama Libraries. This is a new initiative by the Office of Library Technology. The purpose is to share what we're doing with the rest of the library and rest of the campus, and to anyone else that's interested, as well as we hope in the future to bring in some outside speakers to talk about library technology in general, so that we can learn from other experts as well. We have two more talks scheduled with the topics to be determined, October 13th at 10 a.m., which is a Tuesday, and November 11th, which is a Wednesday at 10 a.m. I want to thank Dean Pitchman, who couldn't be here because of another obligation, for supplying the coffee and the cookies and for supporting this initiative. And without further ado, I want to introduce today's speaker. It's Will Jones. He's a senior web developer here at the University of Alabama, and his talk is titled Building an Organized, Automated, and Sustainable Web Development Workflow Using Bower, Grunt, and Github. And before I tell you to take away, don't forget to check out our Facebook or blog. If you go to the library's website, you should be able to find a link to our blog and then a link to our Facebook page. But if you just search for occasional lecture series on library technology, you should be able to find it.
Hello, everybody. My name's Will. I'm a web developer here at the libraries. Seems like most of y'all know me, but for those who don't, I'm going to give you just a little bit of background about what web development has come to in the libraries. Like, we started out very small. It wasn't even a department. And over time, we've grown into a set of 7 people amongst 2 departments. It really came to that now that we have this larger group of people, we really needed ingrained strategy in how to actually develop web projects. Because before, there really wasn't one, because it just sort of slowly evolved into this team. And so, tasked with this, we needed to make the dev flow sustainable, needed to have automation where possible, needed to be easily configured so that it can actually fit the task at hand, regardless of what it is. And most important, it needed to have sort of a gentle learning curve, because we have people from all tech backgrounds, people who have been developing for like 12 years plus, and some people who've just been in it for a couple years. So we needed something that was very approachable to encourage people to be able to develop and contribute. Before we could answer this, we have to really start back at what the issues are in web development. What are the things that are really slowing it down? And so when you're working on your own, generally starting out, people do manual source control. You have a set of files on your hard drive, you open it up, you edit it, and then you just upload it to the server. And then if you're using third-party tools, like other dependencies, like jQuery, is just as straightforward. You just go to the website, you download it locally, and then you upload it to the server. I mean, manual source and management, dependency management by yourself, it's pretty straightforward, until you start working with other people. And then things get a bit more complicated. So, let's take a look at some of these complications with a team of people doing manual source management. So say you're looking at the header for the website, and then you notice an error. Little typo there. Somebody said library. And so you just make your change, upload it to the server. Easy peasy. But then another one of your teammates comes along and they want to add this awesome new service called Radmobile. Except they didn't update their copy of the header file. So they still had the library typo and have now overwritten your changes. But the Radmobile link's up there. So it creates this ritual of every time you want to edit the file, you update it from the server, you make your edits, you double check whether or not it's been updated since you edited, and then you upload. This is it's a giant time sink. It's always hard to tell where the overwrites came from, and just becomes very hard to manage. The solution that's been around forever for this is versioning. there are multiple versioning systems, and their main focus is really to handle all that merging and tracking of changes for you in the files. So one of the biggest things is it'll take changes, which they call commits, that you make to a repository, and then commits from other developers, and then they'll merge them together for you so that you don't have to manually copy and paste pieces of a file into yours and then upload it to the server. You just commit it to the repository and things get merged. And it makes it extremely convenient, and even further than that, it will track your changes for you. So it's makes it very easy to figure out like really what changed and who changed it. So like we can take a look at this specific change here, and we can actually see the lines of code. Wow, that's really small on the screen. You can see specifically the lines that were changed in that file, and it just makes it incredibly convenient. And if you're getting in development or have been in development and aren't using a versioning system, like I highly recommend just start using one. Doesn't even matter what for, just even bookmarks, something. You need to get into that flow because the rest of the world's using versioning systems because they're so valuable. And there are many of them. There's SVN, there's Bazaar, and the one that we went with was Git. Primarily because, I mean, it's a distributed versioning system, which means that each developer can have a copy of the repository on their computer and work on that independent of each other. Some versioning systems are centralized, meaning you have to actually log into the server and then work on the repository there. But with distributed, you can be in an airport and the airport happens to charge $20 for internet. So you're not going to pay that, but you can still work because you got a copy of your repository on your laptop. And Git is also one of the most commonly used. It has the most amount of tools I've seen for a versioning system, as far as like different types of GUIs you can download and different types of projects on the internet I've seen. Like if there's a library we want to use, there's very, very good chance they have a Git repository. And the repository structure is very flexible. Some repository systems like SVN, for example, tend to be very strict in how you actually organize the files in your repository, and the names of some of these things make it difficult for junior devs or people starting out to really get in there. They get discouraged because they'll go to the repository and then they'll see 4 folders and the names mean nothing, and like one of them says trunk, and they don't even know if they're in the right spot. And it's also, Git is also strictly a content versioning control system. Some version control systems actually save the entire file, but Git puts what they call a delta marker on the lines themselves, only the content that's been changed. So you can have a repository of over 1,000 commits and it be much smaller in size than with other versioning systems, because you have to remember, since your repository is tracking all this stuff, all those changes are stored on your hard drive in the repository. So it's really sort of helped with longevity. And also a clincher was SUSE Enterprise actually supported it, so that's nice. And so Git is actually, it's a pretty decent sort of halfway point. It's not too simple, it's not too complex, but it was developed by Linus Torvalds, the inventor of Linux. So it's very nerd focused, very command line focused. So a lot of people find that intimidating. I found it intimidating when I started forcing myself to do it. but there are a myriad of tools and interfaces that can really help you get into Git easily. And the one that we chose was GitHub, primarily because it's free, and it really is the most popular online repository or online set of repositories, like really ever. Every project I've ever seen has a GitHub link on their page, linking to the repository. Even major organizations and companies that use their own private Git servers copy things onto GitHub. So like, Bootstrap, Angular, a lot of Google stuff, a lot of Twitter stuff is on GitHub because they're there for basically publicity, and so that people can contribute, because it's a free system where you can fork any repository you want. So you can make a clone of that and make changes, and then request those changes to be merged in. And the owner of the repository can decide whether or not the changes get merged. So it's really focused to be a community for developers. And one of the big points for us, too, was you can create organizational accounts. So no one user would actually be the owner and controller of all the repositories for your department or college or company. You can use these organization accounts to invite different contributors, and then you can put these contributors into teams, and these teams can all have very different levels of permissions for your different repositories. So some of them might be able to just read the repository, meaning they can see the code, well, really meaning they can copy the code. Some may be able to have write and then permissions, and then some may be full-blown admins, which is giant, especially dealing with large institutions where you have people from varying backgrounds, but you want everybody to have a chance to contribute if they're motivated and want to. You can set people up and not give them too much access to essentially get themselves in trouble. But since it's also versioned, if they do get themselves in trouble, it's very easy to just roll back. And so Git also has like a bunch of other really convenient features. One of the best ones, I think, is like repository browsing. In your organization, it'll just show all the repositories you have. It'll bump up the most recently updated one to the top so that you can immediately click and look through the most recent updates, and also statistics, which can definitely come in handy. Also, I think a lot of people just like it. A lot of people are statistics nerds. Nothing wrong with that. So you can see specifically how many commits people have made, how many additions, how many deletions, and you can see this graph over time so that you can sort of get a gauge about exactly how much work has been done at different points, and even narrow in on specifically what work was done at those points. So for very large, possibly multi-year long projects, it has like a lot of little subtle tools to be able to help this process along. So it's great. We got all the source taken care of, right? No longer manually managing it. Everybody has a clone of a repository. Nobody's going to overwrite each other's stuff. But what about dependencies? You wouldn't really want your dependencies in your repository, because the dependencies themselves have their own repositories. They're the ones that manage that code and whether or not it's been updated. Let's look at what happens with manual management of dependencies in a team. Very similar to when you're on your own, except there's a major difference, is that making sure you're on sync with versions of the dependency. So say somebody creates a new project a couple weeks ago. Developer 1 creates a project. A couple weeks down the line, developer 2 is asked to help with this project because launch date's coming up. Some of his time's been freed up, and so he knows jQuery is being used on the project. So he manually manages dependencies. So he just goes to jQuery.com, clicks the download button, that's it. He apparently loves it. He never really used jQuery before, but it's like really clicking with him. And he uses all over the place the CSS method to select classes for different elements. The only issue is he just clicked the download button. The project that was started 2 weeks ago was on jQuery 1.8, but he downloaded 1.11. And in jQuery 1.9, CSS method completely changed. It changed from accepting a string to an array of CSS classes. So now he has a bunch of code that won't work in what the project's going to launch with. And he has to go back and refactor all that stuff. And now, if you're just using one dependency, that probably won't happen all that much. But there are a bunch of dependencies now. Like, it's not uncommon for a project to have 7 to 15 different dependencies that it's using to help it accomplish a task. So the solution is really automation. And the best tool for that I've found is Bower. Was a tool developed by some guys at Twitter, and it's a package manager for web developers, really. And so what it does is that it actually uses GitHub itself. So it actually scans GitHub and looks to see who's registered themselves as a Bower dependency. It's just a little file, bower.json, just configuration file. And so if you want to install jQuery, you just literally type in Bower install jQuery. Downloads it, unpacks it, puts it in your development folders for you. So it's very easy to automate, and you can control which versions of which dependencies you want to download. You can be specific and say this version in particular, or you can say anything this version above or anything this version and below. And it has very fine-tuned controls about what you can do. And you can use it with your own packages. They don't even have to be registered with Bower. You can point it to your GitHub URL. Just copy and paste your GitHub URL and actually be able to use your own peer dependencies through Bower. So like you can see, this is a list here of dependencies that we're currently using for the new site that we launched recently at the libraries. And you can see there are some that are very common packages, like jQuery. And there we have a definite version. Bootstrap, we have a definite version. But if you look a little bit down, you'll see that there's some that they actually have the URL right by the name of the dependency. And that's because they're not registered with Bower. So we can actually just grab them. And they don't even have to be Git repositories. They can just be zip files on a private server. So it's pretty versatile. And then that way, all a developer has to do when he starts a new project is clone the project repository, type in Bower install, it installs all the dependencies for him. You don't have to go to the website, you don't have to unzip, you don't have to copy it over, it just does it. He doesn't have to worry about versions. That's up to whoever's the mastermind, whoever the lead is of the project can decide what versions to actually use. So it really helps everybody keep in sync. And we found it very, very handy for handling peer dependencies, where we have packages that we want to keep as apps separate from the website itself so that we can use it in other places. But whenever that app is updated, we don't want to have to move files around because that just gets sloppy and you always have to double check. And I don't know about you, but anytime I do manual file management, I get very nervous when I have to upload it to a live server because I have dyslexia, and so that gets fun. But Bower's pretty amazing. I think it's looking pretty good so far. We have that's a pretty decent system. We have a GitHub, handles our source, does a lot of the merging and stuff for us. Then there's Bower, that's going to handle all of our dependencies automatically, just very easy, but there's still something sort of missing, I think, from how a lot of developers start off when in web development. They typically only use what I call catch-all files, because it's the most straightforward way to dive in. There'll be one, maybe two JavaScript files. There's almost always one CSS file. And this can work all right if you're on your own. But if you're in a team, it's very inconvenient. Other developers can't really tell when features are added or removed. And they can't even at a glance tell what features are in the project. Because nobody's going to remember the file sizes. They're just going to see the names are never going to change. And they don't know where you put a feature if they were assigned to pick up on a feature where you left off because you had to go do something else. So these catch-all files, it's really gets you in trouble with larger projects that are just inevitable if you're working with a team. So the key is already been solved, really, with native programming, and that's just modularization, or the separation of concerns. Each feature is packaged uniquely. Each feature has in itself only the things that it itself does. So there's no cross-pollination of actual features. And what this does is that this makes it extremely geared towards not just organization for yourself, so it's easier for you to find what things there are, but for other developers as well. You can just look at this project and see what features there are. There's a forms, there's a menu, there's a news feed. They have a couple of files for global properties and global JavaScript. And then there's some common modules, like a carousel. That's probably for the news feed with images, filters. That sounds like it's something maybe with the forms to filter out text input, like look for email strings and things like that. And the nav bar, that's probably the base functions and things that run the menu. So it's really, to me, an essential, in large projects. Have to modularize, but then you run into that issue of how does it all come together? And because you don't want 50 JavaScript includes on your web page, that's just going to take way too long. You don't even want 35. You want to package everything together. You want to bring it all together into a small amount of files, 1 to maybe 4, really optimize it. But you don't want to copy and paste all that stuff. That goes against everything I've been talking about. Manual lifting, that's what computers are for. They're the ones that do the grunt work. So the solution is Grunt. Grunt is a pretty handy tool. It's what they call a task runner. Really, because I don't think they could think of another name for it. It was written in JavaScript, just like Bower was, because it runs off of a platform called Node.js, which is based off of Node.js is, think of it kind of like Java, to where it's a platform you can install on your computer and run programs, but everything's written in JavaScript, because it's actually a fork of the JS engine for Chrome browser. And it's been incredibly popular in web development these days. And so with Grunt, you don't even have to write tasks. There are already hundreds of thousands of tasks written for you that all these different developers have made, these incredibly convenient tools. All you have to do is configure them. Just tell them what files to run the task on. And these tasks can be concatenation, minification, which for web development is basically it's eliminating all the white space, so you have smaller files, and then obfuscation, which I apologize I don't have an example of, but that's when It's a process where the program goes through and it actually renames variables and function names into smaller strings. So if you have a function of like go get radmobile, it would just change it to A. So it even further minifies the size of your file, and then your load times are much better. So Grunt, it's actually pretty simple. It's a little weird getting into it, but once you do, it clicks really fast. Pretty easy to just configure, to run the task, to minify everything for you. So Grunt can concatenate all of these modules, both their JavaScript and their individual CSS, and then build them all together into minified production-ready files, which is just huge. It embraces the modular scheme to where you can easily add and remove features, and there'll be no gaps. Grunt's going to build everything that's there. And it really is an amazing tool that actually every time now, I was telling Boris the other day, that every time I do something more than once now, I keep thinking, shouldn't Grunt do this? Like, sometimes I got to pull back because I only have to do it twice. But it's a really addicting tool. So, but you know, there's another piece missing. We have this great system, right, where all the code's versioned, all the dependencies are automatically handled. Grunt builds everything for us, does all these like tedious tasks, but we still have this little section of actually getting the code onto the servers. So traditionally, web projects will have a dev and a live site. And you know, it used to be that you would copy code from dev to live to actually make code go live, like Control-V, Control-C. It's a very tedious process. But there are a lot of issues that I've run into with this. Is that when you're in a rush, it does get very tempting to edit live. Like if something comes down from your big boss's big boss, and it's got to be done then, it's very, very tempting to edit live and then go ahead and update it because it's a rush order. But if you're very busy and working on multiple projects like I am and all my colleagues are, it can be very easy to forget sometimes to actually update dev. And so then you've actually broken the dev to live flow, and now the live code is ahead of the dev code. So that means the live code can easily be overwritten by another developer because these systems aren't actually connected. And the messier dev gets, more tempting it is to just work on live. Like working on rotten code it's no fun, you know? and it takes a long time. You have to remember just what is different and try and gauge that when you're going to move it over to live. So you really need a system of automation, and luckily Git offers this. Git has a system of what they call Git hooks, and Git hooks will run custom functions whenever an event happens in a repository, whether it be a commit, checkout, merge, various things really. And GitHub supports Git hooks built in, so it's great. So we've built a system that makes it really easy to get code from dev to live. Like, it may seem like there are a couple more steps, but it reinforces proper dev to live flow, and it ensures that the dev code stays fresh and never rots, which is just key. So what we have set up with GitHub is we have a dev repository on GitHub. That's where everybody contributes. And then once that dev repository on GitHub is updated, it actually automatically updates our dev servers because the dev server has a clone of that repository on it. And that's what runs the dev website. So nobody actually touches the server. So there's this hub system. It actually buffers the flow into Git so that all changes are tracked, monitored. Everyone can look at them, everyone can comment on it, and it's very easy to see if something goes wrong, like track back when things were updated. It makes it very convenient for debugging strange things from time to time. And on top of that, to get the live piece, GitHub allows organizations and regular users to create what they call machine accounts. So you have an account that is just a machine user. No user actually owns that account or really uses it. What that does for us is it holds a copy of the dev repository, which acts as the live repository. And it's actually the other way around. It's actually the machine user is the live repository. The dev repository is a clone of the machine user's repository. So we have yet another stage to get to live. And it can be a bit weird for folks that are newer to the system, but once you get into it, it's very convenient to update live. So all you do is, so you're working on your dev clone. You're testing things locally. They look all right. You push to GitHub, to the dev repository. You ask for feedback. Little exchanges happen on whichever chat client or whatever you're using. Things look all right. They're ready to go live. But you don't actually, say you don't even have permission to make it go live. But you don't have to email somebody and ask. You just go to the GitHub website, and on the dev repositories page, click the pull request button. And what that's doing is, that is a request for the machine user to pull in the changes from the dev repository to live. And there are people that are called gatekeepers, which are the ones that approve the pull requests into live. And these can really be anybody, but generally should be people who have enough proficiency in an area to be able to judge whether or not a piece of code is safe or production ready. And so once the gatekeeper approves the pull request, then that information is merged into the live repository. The live repository also has a Git hook, which updates the live server. So nobody actually touches code on the dev or live servers. And everything's tracked. So we sort of end up with this workflow, which looks a little complicated. If you haven't dealt with versioning systems or Git, some of the words may look a bit strange, but the concepts are actually very simple once you start working with it for just a little while. So we have your dev clone, right? So your changes are ready to go. You push it. Is there a merge conflict, which means have you edited lines that another developer has previously? We'll just say no to make it easy. And then the remote dev fork is updated. That hooks into the deploy or machine user, which updates the dev server. And now, once these things are ready to go live, you make the pull request through GitHub. And if the gatekeeper approves the changes, then it merges the changes from dev into the live repository. That live repository's Git hook then activates and updates the live server. So we have this nice little system where all the rules of development are funneled, automated where they can be, and enforced by the actual process of updating. There aren't any, you don't have to rely on the well-meaning social rules of always update your files, because you're just going to forget sometimes. It's inevitable, especially with massive projects. And so with this system, once you use it just a few times, and you get used to some of the weird words that Git decided to use to describe simple things, then then it's actually, I found it to be pretty successful. Like, this is still very new for us. I myself didn't start forcing myself to use Git until maybe a year ago, I think. And I started forcing myself to use Bower and Grunt, I think 2 years ago. And the new website that the library's launched is actually the first instance that this workflow has been implemented. So we still have run into some kinks, and we're still striving for that ideal workflow to where any developer, if they wanted to, could actually jump in and contribute, which they can, but some things still need to be explained. But I think we found this really nice track, and this workflow, it may not be the most ideal, but I think it's definitely a basis for something that I'm probably going to be using for the rest of my development career, is this system of nobody actually touches the server. Everything goes through a controlled, tracked hub. And then that way we ensure that the code on the server doesn't rot. People are able to contribute and collaborate easily, and really try to encourage a better dev environment and encourage junior devs to try and jump up. Any questions? Any questions? Yes.
Well, a comment and then a question. First, the comment is that Bitbucket, if you remember GitHub, Bitbucket is basically the same deal, right? They offer free accounts if you have an EDU email address. So if you want private repositories, that's particularly valuable.
Yeah.
If you're public, either one. Question for you would be, at what point in this process are you doing and specifically this process, are you doing your Grunt piece? Is that basically when you make it, if you were making updates to your CSS or JavaScript, would you then run Grunt and then do like a push or something like that?
Yes,
Okay.
Essentially.
So basically those minified files are always changing, like pretty much every time there's any sort of update.
Yes.
The source, like the source where it's coming from is less changing less.
And there are actually two main tasks, which actually run multiple tasks, that are very common in Grunt that we also use, to where there's usually a live build and then a development build. And the development build is generally what we use when we're developing, and that doesn't actually minify or obfuscate things, just so that it's easier to debug. And I've gotten okay with, in my IDE, there's a play button for Grunt. So I literally just hit the play button by the dev build, and I'm okay with the pattern of hitting that every time there's an update. But you can actually, there's a Grunt task called watch, which will actually watch all your files for you, and anytime they change, run your dev task for you. So all you have to do is change the file and then refresh your browser, and that's it. And then when things are ready to go live, that's when we run the live build. Because right now, we got a new virtualization server that we were going to use for a lot of this. Like, we were going to use it as for many things, but I was going to put what they call node workers or machine workers on it that would automate the dev to live build, some of those processes, so that we wouldn't actually have to do a push ourselves just to update live, which we have to now. Because the dev server runs the non-minified files and the live server runs the minified files. So like, we stage things on dev, non-minified, then when they're ready, then we run the live build task and push. So like, we do have one extra step now, but generally those are handled by builders or like machines that sort of handle this stuff for us. So once we get that taken care of and get that server set up, that'll be a huge help, I think, especially for newer devs that are still trying to figure out the rest of web development along with this stuff. Sorry, that was a long answer.
No, this is perfect.
Any other questions?
Okay, I have a question.
Hmm.
It is how this is going on GitHub, which is pretty much accessible to anyone,
Mm-hmm.
right? This is software development. So I'm wondering how the university feels about proprietary interests and then, oh, this software was built on our time. We might could make money on that kind of thing. Do you have any feedback on that?
As far as I understand, everything that I develop for the university is public license. So just like Acumen, it runs off of a educational community license. That's the same license I've applied to all of our projects. So I guess until I'm told otherwise, it will be public license. So.
A lot of times, the stuff that we're integrating into these projects are open source, and they may require final product to be open source anyway, so you don't have a choice. It has to be open source.
Yeah.
It's not always true.
A lot of these, like, because we've even custom modified some libraries, and they're on like the MIT license, which requires that we keep it. Yeah, MIT and GPL, they require that you keep it open source. So it sort of plays well together, and I think public is nice too because it's very easy to, in a pinch, get lazy with your code or a little sloppy. And I think, it's easy if you're hiding your code shame on a private server. But if it's public and anybody can see it, I feel like it kind of encourages you to document a little better and make sure your code's a bit more clean. So, just Tom.
Follow up on the issue of licensing. When we began Acumen development, I contacted the tech transfer folks on campus, and it was kind of an interesting conversation. Perhaps now, this is what, 7 years later or something like that. It would be a bit different, but at that point in time, there was really not a clear understanding of open source software. So the argument that I used was that, if you're going to go the commercial direction, there's actually a lot of work that goes into setting that up, and that actually it could be financially detrimental to the university in pursuing that path in terms of, as opposed to looking at it as, oh, we'll make some money on this. Well, you can't necessarily assume that.
Yeah. Yeah, that's not surprising to me at all that more private or proprietary licenses are very delicate. So I think that's why a lot of projects do use like GPL or MIT, which either specify just either reference it or you can't make money off of it unless it's changed to a certain amount, which is reasonable. And I kind of like the idea too, like we're a university, we're supposed to be there as a resource. So if somebody likes a little piece that we did on our site, I want them to be able to just go and look at what we did instead of what they've done in the past where they email around and then eventually it gets back to one of us and then we send them a zip file. And so it's just, it's a nice little system.